Okay, so in this example, this is kind of, those of you who stuck around a little bit after the fire drill, right? I gave y'all a thought problem, right? That to pretend you got your first job maybe, or your first real job or whatever at age 18, and you listen to your math teacher and Clark Howard and other financial people who want you to succeed in your life, and you opened an IRA, which is an individual retirement account, and you should open, by the way, a Roth IRA with that first $6,000 that you earn because you pinch your pennies and because you want to be able to retire someday, right? So you're allowed, I think you're allowed now to do $6,500, but we're just going to use $6,000. So basically then pretend you head off to college and you forget about the account. So it's been sitting in there, earning interest for year after year after year until you retire and you go, oh yeah, I have that retirement account that I opened. So how much money is going to be in the account? Now we have two questions here, right? So we've got our interest rate of 11%. All right, so we've got our $6,000, so that's our principal. That's how much money we're putting in, right? Our interest rate is 11%, which is going to be 0.11. That's not an unreasonable rate for the stock market. It has year after year over the past 50 years averaged right around there. Some years higher than that, some years lower than that. Okay. And how many years is it? How many years is it from age 18 to age 65? That is 47 years. Right? So the first question is, how much are we going to have? Let's do the second one first. How much will be in the account if, so this is a stock account, right? And we're going to pretend like it's getting interest, or it's that 11% growth is being compounded monthly. All right, so we're going to do that one first, monthly. So our formula would be A of t is our principal, so P 1 plus R over N to the NT. So our P is 6,000, our R is 0.11, N, let's see, compounding monthly, that would be N equals 12. And then we're looking at 12 times 47. Okay, so we got to put that in our calculator, and I definitely recommend GeoGebra over a regular calculator here because that's a pretty complicated expression. So we're going to put in, we've got 6,000 times 1 plus 0.11 over 12 to the 12 times 47. Looks right, right? Let's pull this down a little bit. Oh, there we go. And that's a lot of money, right? That is $1,030,920. $1,030,920 and a few cents, right? 59 cents. That's a lot of money, right? And imagine if you did that every year for, the first 5 or 6 years of your working life. Then you might not have to save any money after that. I don't know. All right. So that's a lot of money. Let's talk about, hey, how much will it be if we have continuous compounding? So, of course, that one is P e to the RT. We've got the same 6,000. We've got e to the 0.11 raised to the 47 years. I'm going to do it that way because I think it will make your life easier later in 6.7. So now we're going to put that in 6,000 times. Now here, because again, I don't want to just use e because it's going to use that wrong number. We're going to say exp to the 0.11. So that's going to be e to the 0.11. And then we're going to raise, oops, hold on a second. 6,000 times exp 0.11, and I'm going to just raise that to the 47th. And you can see we do get a little bit more money that way, not a whole lot more, but a little bit more. 1,055,489. What did I say, 489? Yeah, and 2 cents. So either way, pretty darn good amount, right? Okay. All right, so this one maybe, you know, not too far off maybe. So we will pretend, you know, that this person one has just had a child and he happened to have $10,000 laying around that he didn't need. And so he said, hey, I'm going to open a college fund for my child. And we're going to put it in, he found some weird account where it is compounded semi-annually with an interest rate of 6.4%. I don't know what kind of investment that would be, but we're going to go with it. All right. So what is the function that gives the amount after t years? So how much money are we putting in? That is our principal. Our interest rate is 6.4%. Compounded semi-annually, that means twice a year. So n is 2. So we've got p 1 plus r over n to the nt. So we've got 10,000, 1 plus 0.064 over 2 to the 2t. So how much money is going to be in the account after 18 years when the child's ready to go off to college? So we do 10,000, there we go, times 1 plus 0.064 over 2 to the 2 times 18. And so not as big a return. It's a smaller amount of time, and the interest rate is a lot smaller. It's about half, right? So, but still, he's going to have $31,079.15. $31,079.15. And yeah, I tried to do that when my children were born. I said, hey, I've got a little bit of extra cash. How much do I need to put aside now if I want to end up with, I think I said about $80,000 when he goes off to college? And I figured out the amount and I laughed and said, well, I guess that's not happening because I didn't have that much money. But I did put away what I could, and that's helping us, obviously, to pay for his college now. So I'm going to stop here. I do have some extra examples that I'm going to do, but they're just extra examples on the compound interest. So that'll be a different video.